Hello all, today we're gonna learn what is a vector. So, when you tell someone to go 3 blocks south, that's a vector, because you have a direction. So, when you have a direction, that's a vector. Example, go 3 blocks south. Since we have a direction south, that's a vector. So, vector has a magnitude, or it's also called length, and a direction. So, for example, 3 blocks south, we can say 3 south, so magnitude and direction. The opposite of vector is scalar. So scalar, opposite of vector, or it doesn't have direction, so no direction, just number. Let me actually write just number. So we can have 2D vectors or 3D vectors. So let me show an example. So that's a 2D vector, it's y, x, and for example, that's our vector A, that's 2D, and 3D, it has also z, y, x, and for example, this is our vector B, and that's 3D. We also can have vectors in 4D and like 60D, and it goes all the way to infinity. But usually we do not use anything more than 3D because it's hard to visualize it. So, notation for vector. We have column vector, and we write it like this, for example 3, 2, and we also have row vector, and we write it like this, and both of this means the same. And in my practice, most of the people use it in column vector, but row vector is also works just fine. So let's look at vector operations. We have addition, and for example, addition is, for example, we have vector 2 and 1, and we add this to vector 5, 4, and we add this first number to first number, so it's 7, and second number to second number, so it's 5. So that's addition. Then we have subtraction. For example, we have 8 and 7 minus 3 and 4, and we have 5 because 8 minus 3, and also 7 minus 4 is 3. And here is also a picture to show exactly what subtraction means, because addition you have the full length of your vector now, but subtraction is a little bit different. So we have here a, let's see, is 3. It has the length of 3 and 2. It's because we have 1, 2, 3 here and 2 here. The same with b, we have 1, 4. And and this is vector b. So a minus b equals this purple line. So the difference in space between a and b is a subtraction. And they also show it here as a green line, which still is the same. It has the same length and property as a purple line. They just show it to see it better. There is also length or magnitude. And it's basically how long the vector is. And that's how you find length or magnitude. So you have vector in absolute, and it's equals square root of x squared plus y squared, and it also comes from Pythagorean theorem. So for example, we have a vector, let's say 3 and 4, and the length or magnitude of this vector is 3 square plus 4 square, which is 9 plus 16, which is 25, which is 5. And it's just positive 5 because it's an absolute, because of this absolute formula. And for example, so this was our 2D vector, but here if you have 3D vector, it's the same, but instead of, so it's still v. So x squared plus a squared plus b squared plus c squared all the way to 55, for example, on a y squared. Okay, now let's look at multiplication. And multiplication either stretches the vector or makes it longer or makes it shorter or flips the vector. So that's the formula for multiplication. We have constant multiplied by vector. It's k multiplied by x, y, and it's equals x, kx, and ky. So our first state is stretching. If we have k and it's bigger than 1, makes the vector longer. So for example, if we multiply vector, or let me do just below example, if we multiply vector by 5, 3, it's gonna be 10, 15, and it's gonna make the vector longer. Now shrinking. That's when k is less than 1 but bigger than 1. Makes the vector shorter. So for example, 0.5 times 1 and 2. So it's gonna be just 0.5 times 1. And now the third case, it's reversing. And it's when k is less than 0, so it flips. Oh, 1 second. Flips the vector. So for example, we have -3 times 5 and 2. It's gonna be -15 and -6. So it's gonna flip our vector. And that's so far about vectors. And if there are any questions, let me know and I'm gonna answer them. And there's also gonna be a video about practice about vectors, because they can get complicated, but that's the intro to them.